Hey, Dr. Ahmed and fellow alumni, Michael David here. Today I'm walking through my implementation for Assignment 2.2 in COS570, building a production-grade GPT Chatbot using FastAPI and OpenAI's GPT 4.0 Mini. The core goal here was moving past simple script-based prompts into real-world asynchronous pipelines that handle low latency, streaming, reliable tool calling, rolling memory management, and pre-inference security filters. Let's jump right into the code structure. Guardrails and security. Right at the gateway, incoming user prompts pass through secret patterns, Regex filtering. This catches and masks API keys, barrier tokens, or sensitive PII like SSNs before the prompt ever reaches the OpenAI model. We also have an IP-based sliding rate limiter capping traffic at 30 requests per minute. For memory management, to keep context size bounded and avoid running token costs, I implemented a sliding window buffer constrained to 6 interaction turns, configured as max rolling turns here on line 19. Down on lines 112 through 118, the conversation history array is dynamically sliced to drop older messages while locking the system instructions at index 0. Tool execution. We define our tools declaratively via JSON schema in tool registry, specifically getWeather on lines 52 through 67 for live meteorological data, and KB search on lines 68 through 83 for symbols lookup. SSC streaming. When generating responses, we stream tokens asynchronous back to the client using server sent events, yielding chunks in real time and appending telemetry metadata once the stream closes. Now let's start the backend server in PowerShell using UVcorn on port 8000. Once we see the application startup confirmation that the ASGI server is listing, we jump over to our browser to see the live chat client. There, our server has started. When I ask a standard question, notice how the text streaming immediately without any awkward buffering or UI freezing. If I ask, what's the current weather? The model identifies the function schema, pause generation, triggers getWeather on the backend, and injects the live results right back into the response stream. The same happens when asking about course rules using KB search, like what are the office hours? I can establish a project context like mentioning a 60 FPS frame rate requirement, ask an unrelated question, and follow up with what frame rate did I specify earlier? The sliding window retains the state cleanly. To validate everything systematically, we have 2 test layers. First, our PyTest suite in the test app passes 5 out of 5 tests, covering mock streaming, endpoints, integrity, and sanitization. Second, we run eval suite.py, which executes an automated 20 prompt benchmark across 4 distinct domains: tool calls, memory context, safety refusals, and edge cases. Looking at our compiled telemetry metrics in metrics.json and our generated distribution charts, we hit a 95% success rate, 19 out of 20 prompts passing. Our mean time to first token, TTFT, clocked in at 80.5 milliseconds. Overall, mean turn latency sat at 393.59 milliseconds. Our single failed prompt was P16, an out of distribution KB query where the mock store returned a null match, which gives us a clear optimization target for future fallback handling. All project source files, transcripts, generated charts, and benchmark data are pushed to the GitHub repository. This project demonstrates how combining asynchronous fast API routing, schema-driven tool execution, rolling context limits, and Regex guardrails produces a resilient, low-latency chatbot for production workloads. Thanks for watching.